Let's starting. As a part of Master AWS Data Engineering, in this session, we are going to discuss AWS Data Engineering syllabus 2. Master AWS Data Engineering syllabus. In this, we are going to cover 18 modules. So, module 1, we are going to start with the AWS Data Engineering introduction. We are going to understand what is data engineering, and what is Apache data engineering, and then we are going to understand what is AWS data engineering. Okay, then we are going to discuss hands-on demo. These things as part of AWS data engineering module. So this will give idea or overview on AWS data engineering and different services. What is the purpose of each AWS data engineering? So once we understand, now we are going to discuss AWS fundamentals for AWS data engineering. Let's say this is my AWS cloud. AWS cloud offering 200 plus services. AWS cloud offering 200 plus services. In that, we are understanding what are services we are going to use, for our AWS data engineering purpose. So we are going to discuss what are services in this 200 plus services. What are different services we use for AWS data engineering? So next one, we are going to understand what is AWS cloud. As part of fundamentals, we are going to understand what is AWS cloud, how to create account in AWS cloud, what is free tier, how to utilize free tier for our practice purpose. How to utilize free tier for our AWS data engineering practice purpose. And next one, once we complete this language fundamentals, we are going to discuss one service called EC2. EC2 is very, very important service. EC2 service can be used in infrastructure. Like if you want to install anything, we need one virtual machine or physical machine. Here, instead of our physical machine, we are going to use virtual machine in AWS cloud. So that virtual machine, if you want to create, there is a service called EC2. So in this EC2, we are going to install Python. We are going to install PySpark. We are going to install PySpark. We are going to install different softwares too. We are going to install different softwares and we are going to work. So first service will start with EC2, and once this one is completed, very, very important service is IAM. IAM is very, very important service too. Let's say here I said we have 200 plus services, right? We have 200 plus services. If you want to access this any of service, IAM is very, very important. You can create users, you can create groups, you can assign permissions, you can create roles. Lot of activities you are going to learn as part of this IAM service. IAM is very important service. Every service in AWS associated with IAM. Using IAM, we can give access of service. We can put restrictions on service for user level and other service level. Okay. So IAM service is very important service. After IAM, next we are going to discuss prerequisite Linux. So we are going to discuss Linux for AWS data engineering, and these four are AWS data engineering fundamentals, fundamental services, fundamental services. Okay, and then next these concepts: Linux for AWS data engineering, SQL for AWS data engineering, Python for AWS data engineering. These are prerequisites for AWS data engineering. Prerequisites. Let's say I want to work on AWS data engineering. I want to work on AWS data engineering. So here you need prerequisites. Prerequisites. These prerequisites we are going to learn. One is Linux for AWS data engineering, SQL for AWS data engineering. As part of SQL for AWS data engineering, we are going to learn one important service called RDS. RDS stands for Relational Database Service. In this relational database service, we are going to install MySQL, and then we are going to practice SQL on MySQL. SQL on MySQL. Why we need these prerequisites? AWS data engineering, we can provide implementations in two ways. One is SQL, and other one is programmatic. In this programmatic, nowadays for data related softwares, people are using Python. So you need these important prerequisites. One is SQL and other one is Python. So we are covering these prerequisites. Python for AWS data engineering, and then SQL for AWS data engineering in module 6 and module 7. And these prerequisites are very important. And what about Linux for AWS data engineering? Let's say once we deploy our applications, AWS data engineering applications in AWS cluster, and cluster missions are Linux operating system missions. They may give one mission called client mission. Using that client mission, we are going to troubleshoot applications. That client mission is Linux mission. You should have a minimum knowledge of how to interact with Linux operating system. That's why we are covering Linux operating system. And next, why we are discussing PySpark for AWS data engineering. Let me explain it. Here, there is a service called AWS Glue. There is a service called AWS Glue. Glue is used for ETL, or ELT implementation. ETL stands for extract, transform, and load. ELT stands for extract, then load, then apply transformations. To To implement any of these purpose, we use AWS Glue service. In this AWS Glue service, we are going to use Python and we are going to use PySpark programming. PySpark programming. Inside a Glue, we use Python with Spark programming called PySpark programming. So that's why you need minimum knowledge of PySpark, like what is data frame, how to create a data frame, what kind of operations we apply on data frame. Such things we are going to learn first in a PySpark for AWS data engineering. Then, then once you understand this PySpark, right, you can easily understand Glue. You can easily write PySpark programs in Glue framework for implementing ETL or ELT operations. Okay. So once these prerequisites are completed, we are going to start ninth module two and 17th module. These are master AWS Data Engineering Services. Master AWS Data Engineering Services too. We are going to discuss very, very important service S3. S3 is a storage service. Once we extract the data using either ELT or ETL, we load the data first into storage layer, and this storage layer supports unlimited. It is like a Hadoop kind of file system. It supports unlimited storage. It supports parallel processing. So we use this S3 file system for storing huge volumes of data. And then once we store, we are going to write ETL operations using Glue. Okay. And then Athena is very, very important service too. Athena is very, very important service. Let's say I want to write SQL queries on file system, SQL analytic queries on S3 file system without writing programmatic approach. Then Athena is one of the tool provided by AWS to write pure SQL queries on S3 file system. And once this one is completed, we are going to discuss very, very important service called Kinesis. And if any source is continuously generating data, such kind of sources we can configure with Kinesis. Then we are going to store that data into S3. We are going to store that data into S3. So real-time data streaming and processing, we learned one service called AWS Kinesis. And after completing this one, we are going to discuss very, very, very important service called AWS Lambda. AWS Lambda team, very important service. Using this AWS Lambda, we can write extraction logic, we can write transformation logic, we can write service logic. But in AWS data engineering, we use this AWS Lambda for event-driven applications. Event-driven applications. What is event-driven application? Let's say this is my S3 storage. S3 storage. Here I have created a bucket. In that bucket, I have created a folder. In this folder, I am getting file. When file is loaded, when file is loaded, when file is loaded, I want to trigger a event saying file load event called put event. When file is loaded, it will generate an event. In this, I will call lambda function. In this lambda function, what I'm going to do, in this lambda function, what I'm going to do, I'm going to verify this file, this file is empty or not. If it is empty, I do not want to call ETL flow. I do not want to call ETL flow. In ETL flow, let's say I developed 100 jobs or 10 jobs. If this is empty file, then this entire flow returns nothing, right? Yes or no? So no use of creating different resources, no use of running these ETL jobs. Yes or no? So basic validations, basic validations are preliminary checks like file type. We are expecting CSV file. We got a different file. Then no need of calling ETL flow. And we are expecting minimum more than one file. In that more than one file is a mapping file. That file is mandatory to complete ETL operations. If that file is not generated, no need of call ETL flow. Such kind of basic checks, such kind of preliminary checks, we are going to write inside a lambda function. Lambda function is executing in an event. That's why we are calling event-driven applications. We are going to write event-driven applications using AWS Lambda. And then we are going to discuss a very important service called Redshift, AWS Redshift. AWS Redshift we use for data warehousing purpose. Once our ETL operation is completed, final results we can store it into Redshift. Final results we can store it into Redshift. Okay, yeah. Uh, After completing this 14 module, very important module is logging observability with AWS CloudWatch. So I added this service, CloudWatch service, very important service to CloudWatch service. We are using different services in our AWS data engineering. Something happened. Maybe job is failed. Maybe job is struck. Maybe job is running from long time. Job started X time. Still it is running. You want to know what is happening inside your AWS ETL application. Then we will configure a CloudWatch. Every every information of your ETL flow, we will write logs into CloudWatch. Then we will open CloudWatch and we will check or verify application statuses. If completed, when it is completed. If failed, what is happened in fail. So everything we are going to use this CloudWatch logs to. So very important service. 15th. After completing this one, next two services still. One is step functions and another one is Apache Airflow. Yeah. First, let me add one important point here. One important point. AWS step functions. So we may write 10 jobs. In that 10 jobs, first start with job 1 followed by job N. This kind of flow I want to define. For job 1, I want so and so input. Job 2, output of job 1. Job 1, job 2 output. Like this I want to pass. And I want to define this kind of workflow. Workflow means sequence of jobs. And when to execute this workflow called scheduling. Scheduling. So to implement, to define workflow, to define scheduling, we use AWS step functions. AWS step functions. AWS step functions are for pure AWS services. So we can define workflow, we can schedule workflow only for AWS services. AWS having 200 plus services, right? So for any of these services, you can define workflow, you can schedule workflow. So if you are going for AWS data engineering, AWS data engineering projects, industry expects orchestration tools, orchestration tool called AWS step functions. Let's say there are 10 projects, 10 projects, 10 projects, 99.99%, 99.9999% industry uses AWS step functions. We may have a possibility of 0.0000 of 1%, right? This percent industry go only top data orchestration tool called Apache Airflow. If industry not using step functions, then industry uses Apache Airflow for defining workflow, scheduling workflow. Apache Airflow is one of the most popular service. We are going to learn Apache Airflow. We are going to schedule our define workflow, schedule workflow using Apache Airflow. So once we complete this uh, master AWS data engineering, then we are going to discuss end-to-end project, end-to-end project using different services in whatever we learned. Whatever we learned, we are going to implement. We are going to implement end-to-end real-time project. You may take either banking domain or we may take healthcare domain. We will take different scenarios. Then we are going to discuss how we are going to work in real environment. Along with this one, weekends, we are going to see different use cases on AWS Lambda, AWS Glue, AWS Athena, AWS Kinesis, AWS Redshift. We are going to discuss different use cases. Okay, so these are 18 modules we are covering as a part of Master AWS Data Engineering team. Yeah, let's start it. As a part of Master AWS Data Engineering, let's understand what is data engineering. So first important point about data engineering is collect data from different sources and in different formats, then analyze the data. Collect the data from different sources in different formats, then analyze the data is main purpose of data engineering team. Let me diagrammatically explain. Let's say we may have data in different sources. We may have data in different sources. File systems like CSV, JSON, XML, Parquet, Avro, ORC, and data may be presented in RDBMS like MySQL, Oracle, PostgreSQL, Microsoft SQL Server, IBM DB2, etc. Data may be presented in NoSQL databases like Cassandra, MongoDB, etc. Data may be presented in cloud file systems like AWS S3, Azure Blob, Google Cloud Storage, etc. Data may be presented in data warehouses like IBM Redshift, Google Bigtable, Azure Synapse, and Snowflake, etc. Data may be presented in any storage using AWS services, different AWS services. We perform using AWS different services. We perform data ingestion into data lakes. First activity we are going to do is data ingestion activity. Data ingestion activity. As a data engineer, I am not talking about AWS. As a data engineer, we are going to connect this activity. We call it as extracting the data and loading the data. Extract and load. And we load the data into data lake environments. So most preferred data lake environments are data lake means uh, data lake supports unlimited storage. So we have different data lake services like AWS S3, Azure Blob, Google Cloud Storage, Hadoop. These supports unlimited storages. You can store any size of data into these storages. So data lakes, we will take any one of these storages. Once we load the data, we are going to apply transformations. We are going to apply transformations using different technologies. To perform transformations, we use technologies like Python, PySpark, AWS Glue, Databricks, etc. kind of different frameworks to perform transformations on the data. Example, I have 10 years of data, 10 years of data. Let's say near we are getting X festival. We want to retrieve X festival transactions on 10 years data. Then we write a transformation using any one of these kind of technology. And finally, we load the data into data warehouses. Your data warehouse may be Redshift, data warehouse may be Snowflake, data warehouse may be uh, Azure Synapse, data warehouse may be BigQuery, etc. So simply we are going to data engineer going to perform either ETL or ELT. You may hear the term ETL and ELT. ETL stands for extract, transform, and then load. Let me here I have a source. We extract here, we extract here. Then we directly apply transformation, and then we load the data into here. There is no middle layer in ETL. But coming to ELT, what we are going to do? First, we extract the data, ELT. If you are going cloud data warehouses, cloud data engineering, we choose this approach. First, we extract the data and we load the data into data lakes, and then we perform transformations on this data, and transformed data we are going to store it into data warehouses, because we need a history of data first, because we are connecting different sources and we are storing history of data, because these data stores supports unlimited storages. Every time, instead of connecting different sources, we connect sources and we load the data into one location called data lake. On that data lake, we apply transformations. Every cloud data engineering follows ELT approach. Let me explain one more diagram. So once we extract, load, transform the data, now consumers comes into picture. For first activity is a data engineering activity. So data engineering activity. Data engineer collects raw data because data in complete raw format. Sorry, we connect raw data, then we load the data into data analytics ready data. Data analytics ready data. So here our consumers like data analysts or machine learning people or artificial intelligence people. These are consumers to our data. So if it is data analyst, they may use tools like Power BI, Tableau, ClickView, QuickSight kind of tool. They are going to prepare dashboards or reports. If it is data scientist like machine learning, artificial intelligence, these people connects this data source and they are going to predict. Just now I said last 10 years data we transformed and loaded into data warehouse, and then these machine learning and intelligence people connects this data warehouse and predict the future. Let's say coming is X festival is coming in Hyderabad. What are more sales are happening? What product is selling more? In other cities, what products are selling more? So that business can maintain corresponding products so that they can increase the sales. They can also add offers to uh, increase their sales. Such kind of predictions we can implement using machine learning or artificial intelligence kind of technologies. So consumers to our data engineering outputs are data analyst, machine learning, and artificial intelligence people team. Any question in data engineering team? Is it clear what is data engineering? Yeah. Let's continue master AWS data engineering. In that, let's continue. What are different data engineering technologies available in real world? Okay. Yeah. First, let's understand it. First popular data engineering technology we have is Apache data engineering. Earlier, we call it as big data. And the big data term changed to data engineering team. So first important popular data engineering technology is Apache data engineering. In that, people used Apache Hadoop, Apache Spark, Apache Kafka, Apache Flink, and many more Apache tools. Many more Apache tools. And one more important point about this Apache tools are it is free. It is free and these are open source. Open source means, let's say, take a Hadoop. Hadoop complete software related programs you can download If you require, you can modify according to your requirement. And you no need to pay single rupee. It is completely free. So Apache data engineering services are completely free. Then why industry going for other data engineering services or cloud data engineering services? Let's understand clearly. First point. Let's say we have different Apache data engineering softwares. Let's take Hadoop software. Let's take Hadoop software. So Hadoop software is completely free. You no need to pay single rupee for download and install and use Hadoop software. You can download, you can install, you can use without paying single rupee. Apache maintain all free and open source softwares. Okay, software is free, but we have to set up a Hadoop cluster, right? To set up a Hadoop cluster, we need hardware, right? We need a operating system, right? So those are not free. So you have to set up in your own environment called on-premise. So let's say in Hyderabad, I want to set up a Hadoop cluster. Let's say East Hyderabad. East Hyderabad, I taken one data center, means one place. In that, I set up a Hadoop cluster. Hadoop cluster. Let's say I set up around 400 node cluster. 400 node cluster. Let's say team in this East Hyderabad or East Hyderabad, there is a problem, maybe network problem, maybe power problem, maybe natural disasters like continuous raining or earthquake occurred or something natural disaster occur. So your entire East Hyderabad is facing issue. You are not able to access cluster. So to resolve this kind of issues, we need to maintain one more on-premise cluster like same Hyderabad or different region. Let's say West Hyderabad, West Hyderabad, I set up one more Hadoop cluster with 400 missions, 400 node cluster, 400 node cluster. What happened here? We need to purchase hardware. We need to purchase operating systems. We need to recruit IT team like operating system admins, network admins, and then Hadoop admins and different other admins to maintain these data centers 24 by 7 up and run. Yes or no? So this is heavy cost, heavy cost. But initially, I have only very few customers, very few customers. To process this few customers, I need 2 to 5 missions are more than enough. 2 to 5 missions are more than enough, but I purchased 400 missions in one data center. Again, another data center, I purchased 400 missions. So it is heavy cost. Yes, sir. But initially, I have very few customers. To process that customer's data, I require only 2 to 5 missions are more than enough. But I purchased a lot of hardware. I am not utilizing power of this huge cluster. Lot of missions are wasted, but still I paid money because of on-premise. So to resolve this on-premise, to resolve this on-premise issues, to resolve this on-premise issues, cloud technologies were introduced. Cloud technologies are introduced like AWS, Azure, GCP. These cloud technologies were implemented to resolve problems associated with on-premise. Cloud offers pay-as-you-go basis. Means how many resources you use, you can pay only for that. I can create a cluster. Let's say initially, I can create a cluster with five missions for my Hadoop. Every cloud vendor supported Hadoop and Hadoop frameworks initially. Every cloud vendor supported Hadoop and Hadoop frameworks set up on their cloud environment. So instead of on-premise, sorry, Tim, instead of on-premise, we are going with the cloud to set up Hadoop data engineering components. Let's say we set up the 5 node cluster, then slowly my customers are increasing. Then I am adding multiple missions to this existed cluster. Depends upon the requirement. I am adding multiple missions to existed cluster. So here we have a option of pay as you go model. How many resources you used, you can pay only for that resources. So depends upon your business growing, you can add multiple missions to existed cluster. Second one, you no need to recruit hardware administrators, you no need to recruit operating system administrators, and you no need to recruit data center maintenance people, power administrators, etc. All those IT operations are going to taken care by cloud vendors, AWS, Azure, and GCP. You focus on development of your actual business logics. You focus on development of your logics. This IT management is taken care by cloud people. So nowadays, instead of setting on-premise cluster, people are showing interest to set up their cluster on cloud environments. Cloud people supporting Apache data engineering to set up on their cloud environment. So initially, industry started moving their on-premise to cloud environment, and slowly every cloud vendor started introducing their services in data engineering. AWS started introducing their own, Azure started introducing their own data engineering, GCP started introducing their own data engineering services, similar to Apache data engineering. Slowly, people started using mixing Hadoop components and cloud vendor. Let's say instead of Hadoop HDFS file system, instead of Hadoop HDFS file system, people started using AWS S3 or Azure Blob, Azure Blob or or GCP Cloud Storage team. GCP Cloud Storage. These are similar to HDFS file system only. It supports unlimited storage. It supports parallel processing. It supports unlimited storages similar to HDFS file system. Why industry going for Hadoop? HDFS file system. HDFS file system is supporting unlimited storage. What is the problem with if you take Hadoop? Hadoop is completely free. There is no change. It is completely free. But to set up, we have to use either on-premise or we have to use cloud. Instead of on-premise, people started using cloud. Okay, you chosen Hadoop for setuping cloud environment, but you have to install Hadoop cluster. Then you have to recruit Hadoop administrators to maintain Hadoop cluster 24/7 up and run. Infrastructure related, hardware related, operating system related, anything AWS, Azure or GCP people will taken care, but your Hadoop software related, you have to taken care. You have to install, you have to configure, you have to manage. If new resource is required, you have to take one EC2 machine from AWS, you have to install Hadoop, you have to configure to existed cluster. Lot of manual activities you have to do, and you have to recruit specialized people like Hadoop administrator to do activities of Hadoop related. So it is heavy burden. If you go S3 or Azure Blob, Google Cloud Storage, we can resolve these issues. You no need to install any software. These are serverless. You can store any size of data. It will scale automatically. You no need to say, I want 100 missions. I want to 400 missions. No need. You can take S3 service. It allows you to scale any size of data. If you take Azure Blob, it allows to scale any size of data. If you take Google Cloud Storage, it allows to take any size of data. It will scale automatically. Today I stored 1 GB data. Until 6 months, I have only 1 GB data. You can pay 1 GB data charges. So that's why instead of setting Hadoop cluster on either on-prem or cloud, people are going to cloud vendor file system. These are supporting similar style of HDFS file system, similar features of HDFS file system. So slowly people started using cloud file systems like S3, Azure Blob, GCP Cloud Storage. So slowly uh, cloud vendors started introducing different data engineering services. Slowly industry moving from Apache data engineering services to cloud vendors data engineering services. Okay. Yeah. Yeah. Let's continue master AWS data engineering. In that, let's continue what is AWS data engineering. AWS data engineering focus on data collection, data analysis. So collecting data from different sources, collecting data from different sources, and then analyzing those data means transforming the data and loading the data. So mainly AWS focus on collecting the data, analysis data. Here we implement two kinds of operations, ETL operation or ELT operation. ETL stands for extract, transform, and load the data using tools like we can use the tools to extract the data, then transform the data, then load the data into warehouse called ETL or ELT, extract the data, and load the data into data lake, then transform the data, then this transformed data again load into any one of our data warehouse. So most of the time, cloud, we go with this architecture because Whatever, every time instead of collecting different sources, this collected data we are going to maintain in data lake environment. Let me once again clearly discuss. So first we have one activity called data ingestion. As a data engineer, we are going to perform first activity collecting data from different sources, maybe in different format, called data extraction. For that, AWS providing tools like Glue, Kinesis, AWS Transfer Family, many more, AWS Lambda, etc. We have many tools. So we connect to different data sources and we load the data into AWS S3 in a raw layer. Raw layer. Once we load data into raw layer, using different tools to transform the data. To transform the data, we use AWS Glue, AWS Lambda, and AWS Athena kind of tools. We apply transformations on raw data and we load the data into target layer, target layer. If require staging layers, then depends upon our requirement, we may maintain one stage layer and we may maintain multiple stage layers. Stage layer. Example, we are applying uh, transformations on the raw layer and we are directly loading data into target. Let's say we are loading into target. Let's say target data not properly loaded. Not properly loaded, but this report is reflected with that change. So report going to get invalid data or let's say wrong data. Wrong data going to displayed on reports. So to avoid that one, what we are going to do, we maintain stage layer. In stage layer, we load transformer data. Then we are going to do unit testing. Unit testing. And we are going to validate data is properly loaded as expected format or not. Once we can see data is loaded in as expected format, then we move to target layer. From target layer to data warehouses. Data warehouses. It may be Redshift, it may be Snowflake, it may be Azure Synapse, it may be BigQuery of GCP, any target data warehouse. Because these data warehouses supports unlimited storages. Traditional data warehouses having a limitations. Okay, these kind of data collection, data analysis, we can implement using AWS Data Engineering Services team. Clear, right, team? What is AWS Data Engineering? Any question here, team? Yeah. Hmm. Correct. Yes, yes. If you are going for AWS Data Engineering, we use AWS Data Engineering Services. Yes, correct. Yeah. Yes, correct. Similar, instead of Glue, we can go with Databricks, or you can use PySpark also for doing data ingestion activity. That is different purpose. DBT only works in transformation part, not in extracting the data. Let's say I have a file. We go with blue. In same file, I'm getting continuous data, streaming data. Yeah, it may be file, it may be RDBMS table. So we use glue to get data of these kind of store. Let's say a file, here continuous streaming data coming. Then we go with Kinesis. Stream data purpose, we use different technology. But there is FTP, file transfer protocol. Data coming from file transfer protocol. Then we use transfer family. So different purposes. Different purpose, we have different tools. Let's continue master AWS data engineering. In that, let's continue prerequisites for AWS data engineering. There are four prerequisites is required for AWS data engineering team. First, let's understand Linux for AWS data engineering. So I said we create a cluster for data engineering and we deploy our applications into cluster environment. Let's say to submit our jobs and to troubleshoot our jobs, they create one mission called client mission or gateway mission. Client mission or gateway mission. Gateway mission. So from this mission, we submit our jobs and we troubleshoot jobs. All cluster missions are Linux or Unix. Linux or Unix missions. So to communicate with this mission as a support engineer, support data engineer, we need minimum knowledge to communicate with this mission. That's why we need basic knowledge or basic commands knowledge of Linux. That's why we are learning Linux for AWS data engineering. Next one, coming to Python and SQL. AWS data engineering, AWS data engineering, we can implement in two ways. One is SQL approach, SQL based, and other one is programmatic approach. Programmatic approach. In that programmatic, preferred programming language is Python. Preferred Pythoning programming language is Python. So we can implement data engineering solutions, SQL approach and Python approach. SQL is easy to learn, easy to implement. Easy to learn, easy to implement. But problem is SQL is not solution for all problems. Assume we can achieve 80% of solution for problem A. Assume there is a problem A. For this problem, we are providing SQL solution. 80% problem we are achieving using SQL, but remaining we are not able to achieve using SQL. Then we take the help of programmatic approach. We provide that solution, 20% solution, and this result again we convert into SQL. This results again we convert into SQL. Then again we continue SQL. So programming language can provide solution for any universal problem. It may be Java, It may be Python, it may be .NET. Programming language can provide solution for any kind of problems. SQL is easy to learn, easy to implement, but SQL not provide solution for all problems. So wherever a solution we are not achieving, we will take the help of programming. We will continue and we will write both SQL and programmatic approach. That's why we need minimum knowledge of SQL, minimum knowledge of Python. So here in our course, we are covering Linux for AWS Data Engineering. We are covering AWS RDS service. In this RDS service, we are covering SQL for data engineering and we are covering Python for AWS data engineering. These three prerequisites also we are covering. Next prerequisite, let's understand. Next prerequisite is PySpark for AWS data engineering. What is PySpark and why PySpark? Let's say we have 1 GB data, 1 GB data. This 1 GB data, I want to filter based on city column. I may go SQL, I may go Python approach for filtering data on this 1 GB. Let's say this is increased to 10 GB. I can go with SQL or Python to perform filter operation on this data. Then data increased to 1 TB. Data increased to 1 petabyte. If you go these technologies, 1 GB it is super fast, 10 GB it is little slow, 1 TB it is very, very slow, 1 petabyte it will dead slow. It will take hours of time to process these kind of huge volumes of data. If we use PySpark is a distributed parallel processing technology, distributed parallel processing, massive parallel processing technology. It will divide your data into multiple partitions and multiple machines involved to process your data. Data size may be any size. PySpark can process distributed and parallel processing manner so that you will get response very faster. Example, one banking project, they have implemented processing using Python and that application taking 2 hours duration. Same thing we can achieve using PySpark less than 2 minutes. For that bank application, we migrated complete Python programming to PySpark programs. Then same application, same data, PySpark is taking less than 2 minutes. Such kind of improvement we can achieve using PySpark concepts. We can write distributed parallel processing concepts. You no need to write multi-threading. It has a distributed parallel processing concepts. You just focus on writing a job using PySpark. PySpark will take care to distribute your data, do parallel processing. Okay, so industry uses PySpark for these kind of huge volumes of data sets. It may be Apache data engineering, AWS data engineering, and Azure data engineering, It may be GCP data engineering. Industry uses PySpark only. PySpark only. PySpark is from Apache. Even Apache invented lot of concepts, lot of tools on top of PySpark, but still Apache preferring PySpark only. They invented lot of tools on top of Apache, like Apache Beam and many tools to alternative to PySpark, but still not PySpark. It is a Spark. If you write Spark using Python language, we call it as PySpark. Even Apache is not avoiding Spark for in distributed parallel processing implementations too. So if you go AWS, if you go Azure, if you go GCP, in all areas, industry uses PySpark either direct or indirect. Let's say, what is indirect? Blue. Blue is a tool for distributed parallel processing purpose. Glue provides drag and drop feature. Nice graphical user interface. You can drag a source. Let's say S3 my source. You can drag a transformation, filter transformation. You can drag a target. My target is Snowflake or my target is Redshift. You can drag. Then you can map which is source. You can configure source. You can configure transformation to point to source, to point to target. And you can specify target details. These kind of mappings we can do using Glue. Once we save this one, it will generate a code called PySpark. Backend, it will generate code called PySpark. We are not directly writing. We just drag and drag. It is backend is generating what? PySpark code. To understand this PySpark code, later if you want to modify, then you need minimum knowledge of PySpark. That's why we are covering PySpark as part of our AWS Data Engineering course. We are covering PySpark for AWS Data Engineering. All prerequisites we are covering as part of AWS Data Engineering course. Hope you got understanding of what are prerequisites and what is the purpose of each prerequisite. Yeah. Yes. Yeah. Yeah. Let's continue, Tim. Let's continue master AWS Data Engineering. In that, let's continue who can learn AWS Data Engineering. Let me discuss Tim. Who want to start their data career. Let's say you are a fresher, you want to enter into data world, maybe data engineering, maybe data analysis, maybe data science side. I always suggest start your career with data engineering. Uh, so who want to start data engineering career? This is best course for AWS data engineering, best course for data engineering team. And next one, who are working professionals, who are working in different kind of technologies like Java, .NET, testing, and other IT technology. They are working with 5 years or 10 years. They are getting less packages. They want to increase their salaries. AWS data engineering is the best solution and it having lot of opportunities and it pays more money compared to traditional development or traditional tech job roles. AWS Data Engineering having lot of openings and paying huge packages compared to other technologies. And I always suggest people like who are working in BI or who are working in RDBMS side, like database administrators or database developers or reporting people, they have a strong SQL knowledge. They may feel only programmatic approach like Python. Learning Python is not difficult. It is very easy. Our prerequisite concept is more than enough for working on AWS data engineering. So these are first persons to move their career into AWS data engineering team. I said, I said AWS data engineering solutions we can implement using two approaches. One is SQL approach and other approach is programmatic approach. In that programmatic approach, industry preferred industry preferred Python. Python. Maximum, we will try to implement solutions using SQL approach team. Maximum, we will try to implement SQL approach. If SQL is not meeting the requirement, we will take help of programmatic approach. So, who are in SQL background, I suggest join AWS Data Engineering course. You are first person eligible, whether you may be BI developer, you may be SQL developer, you may be data warehouse developer, you may be working in reporting side. You are first person eligible for data engineering team because you have a strong SQL knowledge. Compared to others, you can provide best solutions. So next I can suggest, let's say you are having 10 plus years. Instead of 1 minute. Yeah, let's say you have 10 plus years of experience. Instead of spending time on other data engineering, learn AWS data engineering team. It has lot of openings for experienced people like you. Means at least you have to convert 3 to 4 years of your experience. 3 to 4 years of your experience into data engineering. This course will help you to convert 3 to 4 years of experience into AWS data engineering team. Yeah, that's it for this who can learn AWS data engineering team. And let's continue to as a part of master AWS data engineering. In this session, we are going to discuss AWS data engineering hands-on demo or live hands-on demo on AWS data engineering execution. So this demo class gives how we are going to work on AWS environment for writing AWS data engineering applications. You just concentrate on how we are going to develop. So main intention of this example or demo classes, we focus on how we are going to develop AWS data engineering applications in AWS environment. Okay. So in this, first we are going to start creating S3 bucket, S3 bucket. Then we are going to see how to load files into this bucket. And after that, there is a AWS Glue crawler, and we will give input of this file location. It will read this file. It will read this file, understand column names, and understands data types of each column, then stores that schema information in a table. Let's say column name is C1, data type is integer. Column name is C2, data type is float. Like that, it will store definition of your file. Then we are going to write Athena queries using SQL language on top of file. On top of file. So here we are going to write SQL queries. How Athena knows about this file structure is, first it will connect this blue data catalog, gets the schema details, and based on the schema details, it will read data from this file and displays output for us. So here, what is the role of IAM? What is the role of IAM? Let's say AWS having currently AWS having 200 plus services. 200 plus services. Let's say here we are discussing which service? S3 service. We are using Glue service. We are using Athena service. Athena service for accessing this S3 data. S3 data. So here a service directly cannot access another service. A service cannot access another service directly. So what we are going to do? We are going to create a IAM role. We are going to create a IAM role. Then we will give a permission. We will attach permission of S3. Permission of S3. Then we will attach this role to Glue. We will attach role to Glue. Once we attach, then it get access permission. So one service in AWS cannot access other service in AWS. So for that, using IAM, we are going to create a role. We are going to attach role to another service so that another service having capability to access this service. Okay. So let's implement this step by step. First, I'm going to create a bucket. For this one, you need a AWS account. I already having AWS account. I already logged into AWS account. So first, see once you log in, you are going to see recently visited services. You are seeing lot of services because I already logged in. I already used all these services. That's why I am able to see. In your case, you may created account recently. So you may not see these services. In that case, how you can uh, open S3 is go to search bar, type S3. Then open S3 in new tab. Here we need to create a bucket. Here we have an option called create a bucket. And here I am creating bucket. Let's say Akkem, let's say AWS DE hyphen hands-on demo demo. Okay, I given hands-on demo, hands-on hyphen live hyphen demo. This is my bucket name. Then here, uncheck this option, click on I acknowledge, then click on create a bucket. So here you can see bucket AWS DE hands-on live demo bucket. In this bucket, create a folder with your data. Let's say I have data sets in my C drive. I created datasets folder. In this, you can see there is one folder, AWS introduction. Here, I'm going to load this file. So create a folder to store this data. I'm creating one folder. Folder name is employees. I'm creating folder name employees. Then create a folder. Then open this folder and you can see upload. You can see add file. You can select or go to folder and open this file. Just drag and drop. Just drag and drop. Here upload. Then you can click on close. Click on close. You can see file is uploaded. You just drag and drop. It is going to upload file. So first part is completed. So this part completed. We have created bucket. We have created folder, and in that folder I have uploaded file. Now I want to create a glue crawler. Okay, this crawler I want to say this is my file. Then crawler going to read this file and identifies data types because it is a CSV file. CSV file first row header row. Then based on sample data, it will identify data type of each column. Then stores that information into this glue. So here, let's say this is third step. Here, first I'm going to create a database in Glue Data Catalog. I'm going to create a database, and in this database, it is going to create a table with your file name. Okay, let me go to AWS Glue service, search a glue, and open glue in a new tab. This is my glue. In this glue, you can see here below data catalog. Here you can see databases. Click on databases. Let me remove databases too. I'm deleting existed databases. Click on delete. Yeah. Now you can see add a database. Click on create a database. I'm giving database name is AWS DE hyphen hands-on hyphen live hyphen demo hyphen db. Then create database. Description is optional. Then click on create a database. So step 1 is completed and step 2 is completed and step 3 and step 4. These 3 and 4 steps I am going to do parallelly. Step 3 and step 4 I am going to do parallelly. Let's go AWS Glue. Here your left side pane you see crawler. Click on crawlers. There are existed crawlers. Let's delete this existed crawler. Now here you can see create a crawler. Click on create crawler. Give a crawler name. I'm giving crawler name is AWS DE hyphen hands-on hyphen live hyphen demo hyphen crawler. Then click on next button. Click on next button. Here, see, specify your data location. Here we can use add data source, and here S3 path tree. Click on browse. Here select your bucket name. So this is our bucket, right? AWS DE hands-on demo. Click on this one. Select folder. Up to folder path we have to select, not file name. Up to folder path. Then click on add an S3 data source. Now click on next button. Here we are going to attach IAM role. So I said I am going to do third step and fourth step parallelly. You can select a existing role, okay, or you can create a new role. I'm creating a new role. Create a new role. I'm giving name is AWS Glue Service Role hyphen AWS DE hyphen hands-on hyphen live hyphen demo. Then create this role. Then selected this role. Then click on next button. Then select a database. In which database I want to create a table. So I'm selecting this database. Then click on next button. Click on create crawler. And I want to attach access permission of S3. I want to attach access permission of S3. So here, go to IAM, open IAM in new tab. So go to roles. We created a role called hands-on. So this is hands-on live demo, right? Click on this hands-on live demo. Here we can see add permission, attach policies, select S3 full access. So we are giving full access on this IAM role. Now our group caller having a access permission of S3. Now you can click on run crawler. So go to crawlers, refresh. You can see crawler is started. This is our crawler. Crawler is running. Once a crawler is successfully completed, we are going to see a table. So before that, let me open a file and identify data. So it contains column name ID, name, department, salary, joining data. Okay, let's go here. So crawler is running. Let's wait few seconds to complete this one. Yeah, it is completed. Crawler is completed. It is stopping. Go to databases. Click on this database. Here you are seeing employees table. Did we give employees table name? No. Then how it is taken this table name? Sorry, 1 minute. So here we passed this folder path, right? We passed this folder name, right? This name become table name. Okay, this name became table name. Go to databases. Click on this hands-on DB. Here, this is my name, table name, and database name, and file location. Where is file and what type of file in that location? It is given complete information. Then click on this table. You can see column names. See, these are column names. Same column names. Same column names. Okay, it identified column names and it is identified data types of each column based on the data presented in that column. Okay, so we have completed bucket creation. We have created database. We have completed creating crawler and we have completed IAM role. And now I am writing Athena SQL queries to read data which is presented in S3. Let me open another service called Athena. Let's go here, search Athena. Go to Athena, open Athena in new tab. Here, I am going to create a new plus symbol. Here, I am going to write a SQL query team. See here, once we opened Athena, it is selected this database because only one database in blue data catalog, right? If we have multiple databases, you can select your required database by clicking on this one. So you can click on this one. It will show list of databases. Currently, only one database. In that, let's see, table employees. Now let's write a query. Select query star from employees. Then select this one, run. Click on run button. You can see records. So we are writing simple select statement to get data from file. S3 contain files. On file system, we are writing SQL queries using which technology? Athena. Using Athena, we are writing SQL queries on top of file system. So in this way, we are going to work on AWS environment. You no need separate software to install in Windows or Linux operating system. You need a AWS account. We open different services. We work on corresponding service like this thing. You no need separate environment. You need AWS account. Create AWS free tier account. We will try to utilize free tier for practicing AWS data engineering examples in this way. Yeah. Let me add one important point today. Here, what we are going to do in S3, let's say I am working for a bank called ICICI. So I will create a bucket with ICICI. In that, let's say instead of bank, let's say e-commerce company I'm working. So I'm working for some e-commerce project. I created bucket name e-commerce. In that, I'm getting complete sales data. Let's say I'll create a folder called sales. Here, I'm going to create a subfolder. Let's say uh, uh, first and 01, 01 and 2026. Every day we'll create a separate folders called partitions. So this is, let's say month equal to 1. In that I am creating different folders. Let's another month I will create separate folder. Another month I will create separate folder. Like this, for 1 year I am creating separate folder. Next year I am going to create a separate folder. Like this we will create them. But we are giving this folder path to our crawler, and crawler will take care to read this entire data. So everyday data, maybe e-commerce application, maybe Java or Python or Scala, these e-commerce application, creating a folder in that bucket and writing files. This data may be 1 year, this data may be 5 years, this data may be 10 years. So first time we are going to implement a full load, and every day we are going to implement incremental load. These kind of activities we are going to do. First implementation, let's say I have a 10 years data, we are going to load full load operation, and every day we are running job, we are going to implement incremental operation, incremental load. Yes, yes. Yeah, Michael, tell me. Hmm. 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 Okay. Good. So here we will create a bucket e-commerce. In that year equal to, let's say, 2020, and in that 2020, yeah, I'm I'm adding your point. Let's observe here. So in that month equal to uh, 01, month equal to 01, and in that month I stored 31 days. 0 day equal to 01, and like this I stored all 31 days, and I stored, let's say, 5 years of data. That's a 5 years of data. So this is called partitioning. Partitioning. This is called partitioning. Using Athena, using Athena, here we write a SQL query saying select star from sales table where year equal to 2020 and month equal to 01 and day equal to let's say 20. If I write this one right, because of this partitioning technique, because of this partitioning technique, it will go to directly particular partition, reads the data. If you not maintain these kind of partition, what happen? It will read entire data and applies condition filtering. Let's say 5 years data you have, let's say 20 TB of data, assume. So if you not divide these kind of partition, what happens? It will read this 20 GB data. In that, it will read this particular condition. So if you create these kind of partition, let's say day 20 data is just 1 GB data. Then this query reads only 1 GB data, returns 1 GB data. It reduces cost. It improves performance of your clear, Michael? Yeah. Hmm. Yeah. So it is crawling, first one, if it is CSV, it will crawl header row and it will take a sample data. It will not read entire data of your all files. All files are CSV format only. So it will call header row, it will call sample data to identify data types. Few records, yes, correct. Few records. Yeah, for that one, we are going to update our crawler to check if data may be changed in your data. Let's say your requirement is you added a new column. For schema changes, we again rerun crawler if there is any schema change. So practicing our AWS, yeah, yeah, tell. Let me explain this hands-on demo. Here, let's say user. So we manually created a bucket, uploaded file. In real, real, real flow, real world, what happens is maybe your business application, maybe e-commerce, maybe implemented in Java or Python. This is going to upload a file into buckets. Okay. As a user, we have to create a bucket. In that bucket, creating folder. In that folder, uploading file will taken care by applications. It may be Java application, it may be Python, it may be .NET, etc. So these applications going to create, upload a file. Once file is uploaded, we, we are creating a crawler. Crawler, we are providing input file path. We are attaching permission to access this S3 file. We already created a database DB in Blue Data Catalog. This crawler going to read file. Let's say if it is a file, format is CSV, then it knows CSV file first row is a header row and it will take a few records, sample records. Then based on header row, it will store column names, column 1 to column n. Then each column, it will read sample data and identifies data types, data type 1, data type 2, like that it will identify, stores this schema definition, this file schema definition into Blue Data Catalog. Then using Athena, on top of this file system, we are writing analytical queries. So we are writing SQL queries. So whenever you write SQL query, it will connect this Blue Data Catalog and gets this metadata information. Based on this, it is going to read file, returns results to you. So this entire end-to-end flow we have implemented as part of this hands-on demo.